Alright, so we're in a new unit. Okay, so we've gone over all the different types of functions that there are, we've graphed them, we've dealt with the different type of properties and things of that nature. Okay, so now we're shifting gears from that and getting more into the trigonometry side of pre-calculus. Okay, so some of these things you will see or have seen before, okay, from your days in geometry, but majority of this stuff is going to be new. And we're going to be dealing with trig functions probably for the rest of the quarter, okay, the rest of the semester. So, since we are starting a new unit, if at any point in time you do not understand something, let me make sure I raise my voice so the video picks up on this. If at any point in time you do not understand something, you're going to come in, you're going to ask questions. Okay, you're going to make sure you take the initiative, right? Because you cannot wait till that day before the test and say, I don't understand this, because it's going to be a lot of stuff that we're going to go over. Okay, we're going to go over right triangle trigonometry, which you guys hopefully remember a little bit from geometry. Like what do you remember about that? SOHCAHTOA. You remember what SOHCAHTOA stands for? What about everybody else? Do you guys remember SOHCAHTOA? Sine, cosine, tangent. Opposite. Adjacent, hypotenuse. That's some stuff that you would have seen before in geometry. Hopefully you haven't forgotten that, okay? But now we're actually going to talk a little bit more about their graphs. Now, if you took algebra 2, you would have first graphed sine and cosine, okay? But now we're going to graph tangent as well as all of their inverses. You're going to learn about their inverse functions as well. We're going to talk about those in geometry or algebra 2, so we're going to talk about those as well. So it's going to be a lot of new stuff with a little bit of incorporation of some things you've seen before. So if you do not understand, you need to make sure that you ask your questions in class or ask them during H2H or after school or in the morning. Does everybody understand?
Good morning, good morning, good morning. How many supervisors here on the ridge? Yes?
All right, so today we're going to start out with finding values of trig functions and solving right triangles. Now, more than likely, we probably won't get to the second part of this goal because it is a short class period, so we will finish up on Tuesday. Okay? So, find the values of the trig functions. Now, all right. So you guys see, I have a new board. It's not working as well as the other one, so please bear with me today. So, trigonometry, that means triangle measure. Now, theta, the symbol here, that looks like a circle with a line through it, okay? That is used to represent an angle of a right triangle, okay? They don't use X, they don't use Y. Majority of the time, they'll use the Greek letter theta, okay? So when you see that, it basically represents an angle, more specifically an acute angle in a right triangle. And with that, we can form the 6 trigonometric ratios that define the 6 trigonometric functions. There are 6. You already know 3 of them. What are the 3 that you already know? Sine, cosine, and tangent. But there are 3 others.
I'll go to negative. Sine, yeah, the inverses of them?
Not their inverses, but their reciprocals. You have sine, cosine, and tangent, and then cosecant, secant, and cotangent. I'll give you guys a second to write those down, and then we'll go over them. So the first 3 should look familiar. Again, you guys dealt with these when you did geometry. Sine. You guys should remember SOHCAHTOA is your opposite side over your hypotenuse. Now the opposite side and the adjacent side are based off of where your angle is. In this case, where theta is. Remember, opposite means across, opposite of the angle in which you're given. Adjacent, does anybody know what adjacent means? Not
Next to.
next to. Adjacent means next to, like an adjacent street is right next to the street where you're standing, okay? So adjacent is right next to the angle that you're given, okay? So, the angle is basically going to be formed between your hypotenuse and another side, okay? So whatever side forms that angle with the hypotenuse, that is your adjacent side. It's always important to make sure you know which side is which, so that way you can do your 6 trig functions. Now, everybody repeat after me. Sine.
Sine.
This right here is sine. It is not sin, okay? It is sine. Everybody say cosine.
Cosine.
This is not cos, this is cosine, okay? So when I ask you, to set up an equation or something like that and you have to use sine or cosine, you're going to say sine of theta or cosine of theta, not sin theta or cos theta. Does everybody understand that? Cool deal. Tangent.
Tangent.
Say tangent.
Tangent.
There you go, okay?
Not tane.
Not tane, not tan, tangent of theta. Everybody okay? Everybody understand? Cool deal. Now, their ratios. Remember, ratio is a fraction, okay? You're comparing these two sides to each other. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. That's where the SOHCAHTOA came from, okay? Now, these three other ones that you probably have never seen or heard of before. You have cosecant. Everybody say cosecant.
Cosecant.
Okay, that is abbreviated CSC, okay? But it stands for cosecant. Cosecant is the reciprocal of sine. If you notice, you just switched the sine ratio to get cosecant. Does anybody see that? So to find the cosecant of your angle, theta, you're going to do your hypotenuse over your opposite side. Does everybody understand that? This is secant. Everybody say secant.
Secant.
It's abbreviated SEC. Okay, so secant theta is the reciprocal of cosine. So you flip the cosine ratio to get hypotenuse over adjacent. That is secant. Everyone okay? Cotangent. Everybody say cotangent.
Cotangent.
It's abbreviated COT. Okay? Cotangent of theta is the reciprocal of tangent. So you flip that ratio to get adjacent over opposite. Those are your 6 trig functions that you can use with right triangles. Okay? Did everybody get that down? All right. So let's practice with it a little bit. Or actually, there's 2 more things I want to go over, and then we'll practice it. Okay? Like I mentioned before, cosecant, secant, and cotangent functions are reciprocal functions because, again, their ratios are the reciprocals of sine, cosine, and tangent. Okay? So this is another way that you can represent those 3 trig functions. Cotangent of theta is 1 over tangent. The reciprocal, remember, you flip it. Cosecant is the reciprocal of sine. So you take your sine ratio and you flip it. Okay? 1 over sine of theta is basically flipping that fraction. Lastly, you have secant theta, again, which is the reciprocal of cosine. So 1 over cosine allows you to flip that fraction. So from the definitions of sine, cosine, and tangent and cotangent, you can also derive the following relationships. Tangent of theta equals the sine of theta over the cosine of theta. And cotangent, which again is the reciprocal of tangent, is basically that flipped. Cosine theta over sine theta. So these are basically just another way to represent tangent and cotangent. And the reason why I'm going over these is because later on in this unit, you're actually going to use these, okay? These are what's known as your quotient identities, okay? So you will see these again. I just want to make sure that, you'll be like, what do you have to do with this? Okay. So these are known as your quotient identities. So we're going to find the exact values of the 6 trig functions of theta, okay? You are going to have to draw in this triangle. It's not in your notes, okay? So go ahead and draw it in. Make sure you label the right size, and go ahead. This is the perfect time to practice your thetas, okay? This is a circle with a line, okay? One thing, also go ahead and add in a right angle down there in that corner. I don't want you guys to make any assumptions that, oh, well, it looks like a right angle, so it has to be right angle type thing. I don't really. Go ahead and add that in there. It should have been in there. That was my mistake.
So the triangle is 180 degrees.
Not all the way around. The angles.
Yeah, the angle.
Yeah. So the angles of a triangle, remember, all the angles have to be 360 degrees. Now, let's identify what is our opposite side, what's our hypotenuse, and what's our adjacent. Okay? So listen. Very good. The hypotenuse is the one opposite of the right angle, so 17 is my hypotenuse. Okay? The hypotenuse is always across from your 90-degree angle. What about 8? What is 8?
Opposite.
It is the opposite. Okay? Remember, to be the adjacent side, it has to be right next to the angle. And that's why, what is the adjacent? The 15. Okay? So now that you have all your sides labeled, it's going to be pretty easy to do your 6 trig functions, okay? We're going to first start out with what?
Sine.
Because it's not sin, it is sine of theta. Okay, you always set it up as such, sine of your angle. In this case, our angle is theta. Sine is what over what?
Adjacent over the opposite.
Opposite over hypotenuse. So our opposite side is 8, and our hypotenuse is 17. And that is the exact value of sine of theta. That's it. That's all you have to do. Yes?
You put this in, it doesn't show theta, so you're really assuming theta there.
No, you don't have to worry about typing anything in. When they ask us to find the exact values of those 6 trig functions, they basically want to know what is the sine of theta. What is that ratio? Okay? So when they ask you for the exact values of the 6 trig functions, they want the ratios here. Okay? They want the ratios.
Not the numbers, not the percent of it.
No, not the decimal form, but the actual fraction. Now, one thing I will tell you guys, if you get a fraction and you can reduce it, you want to make sure you reduce it, okay? So say this was 8 over 18 instead, 2 goes into both 8 and 18, so you want to reduce, okay? Let's do the next one. Cosine of theta. Cosine is what over what? Adjacent over hypotenuse. So my adjacent side is 15, and my hypotenuse is 17. Good stuff. Let's keep going. Tangent of theta.
Opposite over adjacent.
Opposite over adjacent. So that's going to be 8 over 15. Is everybody understanding?
Yes.
So far, so good? Pretty simple. Let's work with the ones you've never seen before, okay? That would be, what does CSE stand for again?
Cosecant.
Cosecant. Cosecant is
1 over sine.
1 over sine, or, say again, Tim? Hypotenuse over opposite, okay? So my hypotenuse is, and my opposite is, you can also just flip sine, and you'll get cosecant, okay? What does SEC stand for? Secant. Secant is
Reciprocal and hypotenuse over adjacent.
or
1
1 over cosine. So all I have to do is take cosine and flip it. So I'm going to get 17 over 15. Last but not least, you have cotangent. Cotangent is what? Adjacent over opposite, or 1 over tangent. So I can take my tangent function and just do what to it? Flip it. So cotangent is 15 over 8. Any questions on finding the 6 trig functions? Okay. This one's on you guys. You're doing this one on your own. Make sure you guys drawing that right angle. Should be there. Okay, let's see what you guys got. Okay. John, what'd you get for sine theta?
10 over 26. I reduced it to 5 over 13.
Very good. You always want to make sure that you reduce your fractions, okay? 10 over 26, 5 over 13. So by saying that, you're telling me that 10 is my opposite side, and 26 was my hypotenuse?
Yes.
Good stuff. So then that means that 24 is my adjacent, okay? Cosine of theta. Isaac, what'd you get?
24 over 26, which is reduced to 12 over 13.
Very good. Dejanique, what'd you get for
20 over
what'd you get for tangent? Very good. Okay, you guys are bearing with me because my board's weird. Okay, good stuff. Nick, what'd you get for cosecant theta? Very good, because it's the reciprocal of sine. And Cody, what'd you get for secant? Theta. 13 over 12. Very good. That is the reciprocal of which one? Cosine. And the last one, cotangent. Brianne, what you get?
12 over 5.
Very good. Easy stuff, right? Yes? Good. Okay. Moving forward, taking the same concept, applying it a little bit differently. Say you're given that cosine of theta equals 2 over 5. And you have to find the exact values of the 5 remaining trig functions for the acute angle theta. Now, it says find the exact values of the 5 remaining trig functions. What are the 5 remaining? What do they mean by that? 5 remaining.
Like, so, like, sine, cosine, tangent, cosine, secant. So that's sine, tangent, and then you have your reciprocals.
Sine and tangent, and then you have your reciprocals. They already give you cosine, so you have to find these. Very good. Say it again, Jalissa, what you said? They give you your adjacent side and your hypotenuse because of this particular fraction. So,
Pythagorean theorem.
Pythagorean theorem, because what am I missing?
You're missing your opposite.
I'm missing my opposite side. Now, if you can't see it that well, go ahead and draw in a right triangle. Okay, go ahead and draw in a right triangle yourself. Label your angle theta, and then label your adjacent side and your hypotenuse. Pythagorean theorem will allow you, yes, to find your opposite side, the side that you're missing. And let's see, Pythagorean theorem is what? Raise your hand if you remember Pythagorean theorem. You. Rings a bell. Brian, what's Pythagorean theorem? A squared plus b squared equals c squared. And the one important thing you know about the Pythagorean theorem is c represents your what? Hypotenuse. So when you go to plug in, your hypotenuse is always the c. Does it matter where the 2 goes? No. So I'm just going to put it in front, really doesn't matter if you put it for a or b. So 2 squared plus b squared. Now I'm trying to find b. B is going to represent my opposite side. What's 2 squared?
4.
So 4 plus b squared equals 25. How do I solve for b?
Minus 4 over
Minus 4, so b squared equals 21, and then
square root.
square root. Now if you recall, whenever you take the square root of a number, it's always plus or minus, but in this particular case, do we want the minus?
No.
Because it represents the side length of a triangle, and we can't have a negative measurement for a side length, so we only want the positive. Now it says exact,
4.5.
but is that exact?
It's not a fraction.
It's, well, when it says exact, they don't want that decimal approximation. They want that radical broken down, simplified if it can be. So you basically have b equals the square root of 21. Okay? Now, does the square root of 21 simplify down to anything nicer?
No.
No, because you just have 3 times 7. So my opposite side is the square root of 21. And that's what I use to find my remaining 5 trig functions. Does everybody understand that? So sine is what over what? So opposite over hypotenuse. And I'll leave it just like that. So I can't simplify the square root of 21 over 5. I got a radical at the top and a regular number at the bottom. What about tangent? Anybody? Opposite over adjacent, so that is square root of 21 over 2. So far, so good? Cosecant. 5 over radical 21. But you cannot have a radical in the denominator, so you can't stop here and say that you're done. How do I get that radical out of the denominator? Rationalize it. So I multiply by radical 21 over radical 21. This is how you get rid of the square root in the bottom. It's called rationalizing. Well, when you multiply the square root of 21 by the square root of 21, the radicals are going to end up going away. So you're just left with 21 at the bottom. But on the top, you'll have 5 times the square root of 21, and then that would be your cosecant of theta. Yep. Secant will be 5 over 2 because it's just the reciprocal of cosine, which was given to me at the beginning. And then cotangent is the reciprocal of, say it louder, tangent. So I flip tangent, but I have to rationalize to get
2 right to 21 over 21.
And those are my remaining 5 trig functions. Questions? You're going to try this one on your own. So this time tangent of theta equals 1/2. You're finding the remaining 5 trig functions. So what does the 1 represent? 1 represents the opposite, and 2 represents the adjacent. So to find my hypotenuse, I needed to do the Pythagorean theorem. So 1 squared plus 2 squared equals c squared. I was looking for my hypotenuse. So 5 equals c squared. So square root of 5 was my hypotenuse, yes? Okay. So now to my remaining 6, that's sine. Which other ones? Cosine. Cosecant. Secant. And then cotangent. All right, so what is sine? 1 over the square root of 5. Can I leave it like that? So when I rationalize, what do I get? Cosine. 2 over radical 5. Can I leave it like that? So what is it? Cosecant. Radical 5 over 1. If you take the original fraction, you got this one right up here, and you flip that, yes, that is fine. Because if you took the 1 after you rationalized the denominator, you would have to rationalize again just to get back to this point. What about secant? Because you just flip cosine, and lastly, cotangent is 2. How is this? 2 over 1, which is, how is this? No, like how is this stuff so far?
It's simple.
Simple? Okay. I've been saying 2, I'm like, I got that already. It's 2 over 1. No. None of this should be anything too scary. Question? No, you do sine then 45. You would do it backwards if you were like working with icons. Okay. Okay. So you will be asked often to find the trigonometric functions for specific acute right measures. This should look familiar, okay? When y'all were in geometry, they actually had a reference sheet for you guys, and these were your special right triangles. They never changed, okay? They never changed. And at 45, 45, 90-degree triangle, if two angles are congruent, that means the two sides are congruent. So that's where they're both labeled x. The hypotenuse in a 45, 45, 90-degree triangle was just your legs times radical 2. So no matter what x was, say x was 7, then your hypotenuse would have been 7 radical 2. Now this x that's up there on the hypotenuse, this can also be written as x square root 2, okay? The x is not underneath the radical. I don't want you guys to think that. It was just the one on the side, the copy and paste we were doing, that's what I went with. Over here, over the 30, 60, 90-degree triangles, this one was a little bit different. Your smallest angle was across from your shortest side, which was x. Your hypotenuse was twice as long as that short side, and the side across from the 60 was x times the square root of 3. Okay, that x is not underneath that radical. So if the side across from your 30 was 6, that means your hypotenuse was what? 12, because you would just double it. And then the side across from your 60 degrees, if x was 6, 6 radical 3. So, what you guys are about to do is you're about to find the 6 trig ratios for each of the acute angles in these special right triangles. Now, when you look at these special right triangles, what acute angles do you see? 45, 30, and 60. So when it says find the 6 trig ratios for each of the acute angles in the special right triangles, that means you're going to find the sine, cosine, tangent, cosecant, secant, and cotangent of 30 degrees. So you're going to use 30 to find all 6 of those. Then you're going to do the same thing, except you're going to do it for 45 degrees. Okay? And then you're going to do the same thing for 60. The reason why is because it says you will be asked often what these different trig ratios are for these angles. Okay? You will see these again. So I want you guys to go ahead and derive them now. So take the rest of the class to find the sine, cosine, tangent, cosecant, secant, and cotangent for 30, for 45, for 60. Okay? So go ahead and do that. Make it nice and neat, so then that way you can look back on it. So you guys are finishing this up for your homework, but just to make sure that you guys are good, okay? Let's take a look at sine 60, okay? Here's 60. This would be my opposite side. This would be my adjacent. This would be my hypotenuse if I was doing the sine of 60 degrees. Well, sine is opposite over hypotenuse. Your x's would end up canceling each other out, so you would have the square root of 3 over 2. So the sine of 60 degrees is the square root of 3 over 2. You guys are finishing up this chart for homework. Okay, so I should have all 6 trig functions for 30 degrees, 45, and 60.